So we're going to change our tangent squared plus 1. As I told you guys before, tangent squared plus 1 is one of our Pythagorean identities. And you might not have remembered how to get there. So we're going to make it up ourselves because our Pythagorean identity is sine squared plus cosine squared is equal to 1. Now, how do I get tangent? Tangent is really the quotient identity of sine over cosine. So let's go ahead and try to make our own tangent there by dividing everyone by cosine. Cosine squared. And as you can see, we divide everyone by cosine squared. Now, sine squared over cosine squared is tangent, and cosine squared over cosine is 1. And I want to leave the 1 over cosine squared here. And we'll see right now that this will actually cancel out with the cosine that's already there. So when we go ahead and substitute it back in, my 1 over cosine squared with the tangent squared plus 1, it actually is going to cancel out because we have cosine on the bottom, leaving me 1 cosine left on the bottom. So cosine divided by cosine squared is still going to be 1 over cosine, which is the reciprocal identity for secant x. So let's go into our next problem, 1b. We have this crazy cosecant, cotangent, tangent, and sine, and that has to become cotangent and cosecant. So we're gonna go ahead and change everything to sine and cosine. We're trying to make the left side look like the right side. We'll try to, I feel like we want to get the more difficult side to look like the easier side because we have more material to work with. So we're gonna change cosecant to 1 over sine. Cotangent itself is our quotient identity, which is cosine over sine, right? It's a flip version of tangent. And tangent is sine over cosine. Now, the sign on the bottom is just sine, so we're just going to write it. Now, our next move is to fix these fractions over fractions by writing one big fraction on top and one big fraction on bottom. So on the top, we have a common denominator already of sine, so we can just combine those together, 1 plus cosine. And on the bottom, we don't have a common denominator, so the right side needs a cosine. So I'm going to go ahead and write cosine on top and cosine on bottom. Remember, I'm just changing the way it looks. I'm not changing the value. And now we do have a common denominator of cosine x on the bottom. So let's rewrite that now to be sine x plus sine cosine all over cosine x. Now, as you can tell now, this is what I usually call the Tower of Terror. We have one big fraction on the top and one big fraction on the bottom. And I can multiply this by the reciprocal now. We're going to flip that denominator over. The top always stays the same when I'm doing this trick. And the denominator flips over to become cosine on top, followed by our sine x and sine cosine on the denominator. So again, this is just the reciprocal of the denominator. And we don't have these two fractions on top of each other now. We take our division and we make it into a multiplication. Now, usually something will divide out here and nothing obviously stands out until you realize the denominator has sine. So let's go ahead and factor that out on the right side. And we're left with 1 plus cosine x, which is on the top left corner there. So they can divide out 1 plus cosine and 1 plus cosine. So we're going to go ahead and divide those out, the 1 plus cosine and 1 plus cosine. And we're left with a cosine on top, followed by 2 sines on the denominator. So we're going to write cosine over sine, which is kind of what we're looking for. Cosine over sine is really our cotangent, and our cosecant, which is 1 over sine. And we're done, because those are identities. So we just demonstrated two of our most popular methods. One is Pythagorean theorem, and the second one is changing everything from sine to cosine and then using a lot of algebra 2. So let's go into our problem number 2 now. We're going to solve the equation. So what is sine of 15? Well, sine of 15 isn't a special angle, but we do have something called half angles because there's actually a couple ways that we can do this problem, and one of the easy ways, since I know 15 is half of 30, is 30 divided by 2 is 15. So let's go ahead and write out our half angle formula there, which is sine of x over 2 is equal to plus or minus the square root of 1 minus cosine x over 2. And that's in your notes. And if I say 15 degrees is really 30 divided by 2, hey, why don't we try using this formula? Because we know what the cosine of 30 degrees is. So let's go ahead and set it up. The sine of 15 degrees is really sine of 30 over 2. So x is really going to be 30 for us. We're going to copy that to be plus and minus the square root of 1 minus cosine. And the angle that we're bringing over is not 15, but 30, because we know what the cosine of 30 is. We can draw a triangle. As I always tell you guys, if you guys don't memorize, you can always draw your unit circle. And in this case, our 30-degree angle will lead us with a short side of 1, hypotenuse of 2, and third side square root of 3. In quadrant 1, these should all be positive. So we can go back and rewrite this now with our cosine of 30. And as you can tell, the cosine is adjacent over hypotenuse, which is going to be the square root of 3 over 2. So that's a little messy. Square root of 3 over 2. And all over 2. That's also inside the square root. Now to rewrite this, we don't really want the square root inside and the fraction inside at the same time. We can bear with one of them. So let's go ahead and fix that. Where our common denominator on the top is 2. So it'll be 2 minus square root of 3 all over 2 again. And we're going to rewrite that to say, hey, multiplying by the reciprocal is going to be 2 minus square root of 3. Oh, sorry. Yeah, square root of 3. All divided by 2 times 2 is 4. And the square root of 4 is going to give me a 2. That looks like a 2, but it's really a 3. Okay, our next problem, I see 285. 285 is not a 30, 60, 90, or 45-degree angle, but we could make it into a 45 and 240. And the trick is, if you see a 5, the chances are it might be a 45-degree angle. So go ahead and subtract 185 by 45, and we end up with 240, and we know what 240 is. So let's go ahead and write out our identity for tangent, our sum angle. It's tangent A plus tangent B all over 1 minus tan, or tan A, tan B. And we're going to copy our angles A and B into the problem. Angle A is 240, and angle B is 45. And if you need to pause to take a look at what we're writing here, that's not a problem. And 1 minus tan, which is tangent of 240 and tangent 45. I'm going to go ahead and draw our two angles now of 240 and 45. As a reminder, our 240 is what type of angle? It's a 60 degrees, right? The way you figure out our reference angle is you can think about what's the biggest angle I can divide 240 by, and apparently it looks like 60. And that's going to give me a long tall side and a short adjacent angle. And in quadrant 3, they're both going to be negative. In 45, it's a 1 square root of 2. And we're going to copy those fractions over on our problem. So tangent of 240 is going to be opposite over adjacent. I like oftentimes just filling in these parentheses, so I know I'm just plugging in the fractions because they're ready to go. So again, my tangent is going to be a negative square root of 3 over a negative 1 at 240 degrees. And I'm just going to copy that over again because it's tangent 240. And then the tangent of 45 degrees is 1 over 1, which is 1. We're going to rewrite this, try to simplify our fractions again. Since we are dividing by 1 only, it's just going to be a square root of 3. And a negative divided by negative becomes a positive. All divided by 1 minus a negative and negative become a positive. So 1 plus square root of 3 over 1. Sorry, I made a mistake, called it a 2. And then we learned in class that we don't like square roots on the bottom. So I can't just multiply by square root of 3. We're going to multiply it by what we call the conjugate. And the conjugate, people like calling it the opposite. It's not really the opposite. It's really the sign in the middle changes. So we don't have a middle term when we distribute those parentheses, those binomials. So the top will become squaring a binomial, which is square the front, square the back, and double the middle. And that middle term was going to be the square root of 3. So we have 2 square root of 3's. And square root of 3 times square root of 3 is just 3. On the bottom, we don't have a middle term, so it'll be 1 times 1 is 1. Square root of 3 times square root of 3 is 3, so it'll be 1 minus 3. And as we simplify that, 1 plus 3 is 4, plus 2 square root of 3 all over 1 minus 3 is negative 2. We're going to divide negative 2 by both these values. And so 4 divided by negative 2 is negative 2. And 2 divided by negative 2 is going to be a negative 1 left over square root of 3. And then so that answer there's going to be a negative, and tangent in quadrant 4, because the triangle, the angle 280 degrees is in quadrant 4. I'm going to draw that out right now. So 280 degrees, 285 degrees is someplace in quadrant 4. And we know that all students take calculus in quadrant 4. That's going to be a negative. And that my answer there is negative. Just to back that up again.